All right, so I'm going to go over a problem on writing on the mole. So if you want to go into that extra practice packet and go and find where it says the mole. So just a reminder, when we're talking about the mole is the same thing as the molar mass, so the number of grams that we can find on the periodic table, which is also, and the mole is also equal to Avogadro's number, which is 6.022 times 10 to the 23rd. And that can be either particles, molecules, or atoms. So remember, atoms would be something individual, so like copper, where a molecule would be something bonded. So that would be, hydrogen gas, so H2, or water. So those would all be examples of your molecule. So molar mass, we're just going to quickly go through. So ammonium is NH4 plus 1. Sulfide is S minus 2. So this is going to create NH4 parentheses 2S. So we have that polyatomic in there. So you go to the periodic table and you find nitrogen. So you find N, which is on your periodic table, 14.01. Okay, but we have two of them because it's in parentheses, so times 2. And then you have H, which is 1.01 times 8, because we have 4 times 2, which is 8. And then we add that to sulfur, which we find sulfur, which is 32.07. And we would just add all those numbers up to get the final molar mass. So that's how you find your molar mass. There's already a video on. It's not these exact problems, but if you go on campus, you'll find that there's already a video talking about moles and grams. So I want to go through one that deals with moles and molecules, because molecules and particles, because there was not one like that. So this is where we have to use Avogadro's number. So that's 6.022 times 10 to the 23rd. And remember, that can be used as molecules, atoms, particles, but it's all equal to 1 mole. So just like if I were to say 1 dozen, you would say that's 12. Well, if I were to say 1 mole, that means you have 6.022 times 10 to the 23rd molecules, particles, atoms of whatever substance you're talking about. And then if we put that on the scale, that will tell us how many grams it weighs, which is where we get our molar mass. So if we have 8.90 moles of oxygen, remember oxygen's a diatomic, so it's going to have a little 2 there because of our Hunkelbreath. We always put our given over 1. So we're going to focus on our units. So we're trying to cancel out moles. So we need the mole portion of the equality, which is the 1 mole. So I want to put the 1 mole on the bottom, which means Avogadro's number goes on top. And since I'm talking about molecules, I'm going to use the unit molecules. But I can use the unit atoms as well, not for this one because it's oxygen. So now if I look at my units, moles cancel out, leaving me with molecules. So then all you would do is multiply 8.90 times 6.022 times 10 to the 23rd. And then that would give you your answer. This has 3 sig figs, so we would want our answer to be 3 sig figs. Now the next one is a little different because this time it's giving us 5.24 times 10 to the 24th atoms of carbon. So notice we're using atoms because we're talking about an individual particle of carbon. It's not a compound or a molecule. So now this time we are canceling atoms. So again, remember this can be atoms, this can be per mole, this can be particles per mole. So this time we want the atom portion on the bottom, which means Avogadro's number, because that is the atoms portion, goes on the bottom, which means the 1 mole of carbon goes on top. So now looking at units, atoms cancel out, leaving us with moles. So this time you would divide 5.24 times 10 to the 24th divided by 6.022 times 10 to the 23rd. And then just make sure you're calculating this and plugging it in correctly. So this is where you would type in your calculator, 5.24 E24 divided by 6.022 E23rd. And you should get a smaller number. So if you get something times 10 to the 40th, then you calculated it incorrectly. There's already a video on empirical formula, and there's already a video on percent composition. They're not these exact problems, but then you can come back and you can try to get these